Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to continue solving KSET 2025 Physical Science question paper. In the last video, we stopped in the 42nd question. The question says if psi which is equal to a chi1 minus b chi2 plus c plus I d chi3 is a state where a, b, c and d are the real numbers and chi1, chi2, chi3 are the mutually orthogonal state functions, then the norm of psi is. So to solve this question, I have rewritten the question. Now to find the norm is defined as the square root of the inner product. Inner product is bra of psi and the ket of psi. I can write this equation as square root of psi star into psi. What is the psi star? Star means it is a complex conjugate of a given function that is represented by the star here. Okay. Yeah, let us solve this question. First, we will solve inside the bracket, inside the square root. Then we will solve square root for square root. Okay. Now, we will solve for the inner product, that is psi star psi. So what is the psi star means? A star into chi1 minus b star into chi2 star plus c plus id star into chi3 and remaining psi I'll write as it is, that is into a chi1 minus b chi2 plus c plus id chi3. Now solving for this, for the real number, complex conjugate remains as it is, and for the mutually orthogonal state functions, that is xi star 1 into xi 1, it will give rise to 1. That is what I said, that is xi 1 star into xi 1, the value will be 1. Whereas for mutually orthogonal state functions, xi 1 star into xi 2 will be 0. So we will get the final, in the final result we will be getting here 4 terms. So on solving this inside the bracket term first, that is xi star into xi, we will get a star. I can write it as a, that is complex conjugate of the natural number or the real number, or will be a itself into xi 1 star minus b star is b only, xi 2 star plus complex conjugate of c star is again c, plus here complex conjugate of I is a imaginary number here. In the imaginary number, instead of I, we'll get minus I. Complex conjugate of plus I is minus I. Into d star, it will be d of chi3 into chi3 star into a into chi1 minus b into chi2 plus c plus id into chi3. Now on multiplying and using these conditions, on multiplying I get xi star xi to be equal to a into a is a square, minus of minus plus b into b is b square, plus c into c is c square, minus id plus id, it will be minus id whole square, right? I is a imaginary number. Our value for I is square root of minus 1. So I square, it is equal to square root of minus 1 whole square. Square root get cancelled, we get the value minus 1. So minus 1 into minus, it will be plus 1. So xi star xi value is a square plus b square plus c square plus d square. So what they have asked to find the norm. Norm is represented by the symbol like this. Norm of xi, which is equal to square root of a square plus b square plus c square plus d square. So which is the right option? So the option C is the right option, that is square root of a square plus b square plus c square plus d square. Let us move on to the next question. The next question we have is, Given the following wave function, they have given the six wave functions, that is xi1, xi2, xi3, xi4, and xi5, xi6 with respect to x. Identify the physical acceptable wave function for a bound state. This is a question. So, for a physically acceptable bound state, the wave function, it should satisfy the following conditions. What are these following conditions means? It should be a single valued in the sense, for a single value of x, there should be a single value of xi function. So here in the option 4 we can see two different values of xi, so option 4 is deleted. Now the second condition is the wave function should be a continuous, and its first derivative also must be a continuous. You can see a xi3 function, it is having a sharp curve. If any curve which is having sharp means its first derivative, it is a discontinuous. So xi3 is also deleted. Now moving on to the next condition, the wave function must be finite everywhere. You can see the xi1 here, it is not finite because a xi1 goes to infinity, so it should not goes to infinity, it should have a finite value. Next, the condition is it should be a square integrable. What does this square integrable means? For a bound state, the probability of finding the particle must be finite means, whereas as x tends to plus or minus infinity, this xi should approach to 0. This is the meaning of square integrable. So you can see the sixth option, and for the second option this condition is satisfied. Where coming to the fifth option, it is not a bound state, it is a unbound state. So I can say my option fourth is the right option, that is xi2 and xi4 or the physically acceptable wave function for a bound state. Let us move on to the next question, that is 44th question. In this question, we have the potential energy of a simple harmonic oscillator in the xy plane is given as V of x comma y, which is equal to half of the m omega square x square plus 4 times of y square. Then the energy levels of the oscillators are given by the expression that is equal to what they have asked. So the potential they have given for 1D simple harmonic oscillator, the potential was V of x, which is equal to half of m omega square x square, and the corresponding energy eigenvalues or the energy levels, that is ex or en, you can call it as n plus half h cut omega. So for 2D potential, we have they have given the equation. So for the 2D potential, that is V of y, which is equal to half of m omega square y square. So here we are having half of the m omega square 4 times of y square. So V of y will be equal to half of the m 2 times of omega square, I can write it as, that is 4 times of omega square, I can call it as 2 times of omega square into y square. I am calling this to be equation 1 and this to be equation 2. On joining this both equation, that is V of x comma y, I get to be half of the m into omega square x square plus half of the m into 2 times of omega square and y square, right? So now the energy eigenvalue will be n plus half. Instead of n, you can write it as nx plus half into h cut omega plus ny plus half into h cut. Instead of omega, here you will get 2 omega. So instead of nx and ny, here they have given the integer n1 and n2. So which option is the right option? Option 2 is the right option, that is e of n1 comma n2, which is equal to h cut omega n1 plus half plus 2 times of h cut omega n2 plus half is the right answer. Now let us move on to the next question, that is a 45th question. A particle of mass m is moving in a potential V of x, which is equal to 0, where x is less than a and greater than 0, infinite otherwise. Evaluate the expectation value of its energy when it is in the state psi of x, which is equal to n into sine cube pi x divided by a. We need to find the expectation value for this wave function. Yeah, let us solve this question. Yeah, we are having the question they have given here as psi of x, which is equal to n into, let us see this question, n into sine cube pi x by a, n into sine cube pi x by a is the question given. So we need to find the expectation value. So the expectation of this it is given by expectation value, which is equal to integration from 0 to a, because the limits are given to be 0 to a, that the limits is for the infinite potential well they have given the limitations. So it is from 0 to a, xi star of x into h cap into xi of x into dx. What is this h cap? H cap, which is equal to minus h cut square divided by Hamiltonian operator. It is 2m dou square divided by dou x square is the Hamiltonian operator. So the expectation value, which is equal to 0 to a psi star into x, h cap psi of x into dx. Here the psi of x, it is a normalized, it is not a normalized wave function. First we need to normalize. For that, we need to use the inner product formula, that is from 0 to a psi star x into psi of x, that is a normalization condition, to be equal to 1. We need to equate it to 1. This is the formula to find the uh, normalization constant, that is the value for n. Now 0 to a xi star of x is n star into sine cube, it remains the same because it is a complex conjugate. In this we don't have a complex numbers to conjugate. Pi x divided by a into xi star x into, here it is not the xi star, it is xi x. By mistake I have written like this. Let me erase. Okay, yeah, let me continue now. Here it will be n into sine cube pi x divided by a, which is equal to into dx, means integration we are doing means it should be having the dx value. So it is dx, which is equal to 1. Now it is from 0 to a n star into n, it will be n square. Sine cube into sine cube, it will be sine to the power of 6 pi x divided by a into dx, which is equal to integrating with respect to x, which is equal to 1. Now after integration, sine cube of x into integration of sine cube of sine to the power of 6, that is sine cube square or sine to the power of 6 into dx, which is equal to how much? It is a standard integration value. I have the integration value to be equal to phi a divided by 16. After applying the limits also, I get the value to be phi a divided by 16. On substituting, I get n square, which is equal to phi a divided by 16, which is equal to 1. Now n square will be equal to 16 divided by phi a, or n, which is equal to 4 divided by square root of phi a, right? This is the value for n. Now we got the normalized wave function, that is psi of x, which is equal to 4 divided by square root of phi a into sine cube of pi x divided by a. Now applying this in this formula, so we get the expectation value to be equal to integration from 0 to a xi star, it is number, so it is not an imaginary number to do the complex conjugate. 4 divided by phi a sine cube pi x divided by a into h cap, instead of h cap minus h cut square divided by 2m dou square divided by dou x square into psi of x. What is the psi of x? Psi of x is again 4 divided by square root of phi a into sine cube pi x divided by a into dx, right? Now 4 divided by square root of 5a, 4 divided by square root of 5a I can take common. I not common, take out from the integration because these are the constants, minus h cut square divided by 2m. So expectation value will be equal to, it is 4 fours are 16 divided by square root of 5a into square root of 5a. It is again 5a minus, I'll take here out, h cut square divided by 2m. What is left inside the integration? 0 to a. Sine cube pi x divided by a into dou square divided by dou x square into sine cube pi x divided by a into dx. First, I need to solve this partial derivative twice of sine cube pi x divided by a, that is a Laplace transform. So let me solve this first. So for solving this, I'm getting into next slide. Let me rewrite the things again. What is that? Dou square divided by dou x square of sine cube pi x divided by a, right? If I do partial differentiation one time, I get 3 times of sine square pi x divided by a. Again, differentiation of sine pi x is cos pi x divided by a. Differentiation of pi x by a is pi divided by a, right? Now again I need to partially differentiate taking the UV rule. I can take 3 pi by a to be constant outside this differentiation. This I'm taking as u and this I'm taking as a v. So sine square pi x by a I am keeping as it is for the first time, and differentiation of cos of pi x divided by a, it will be minus sine of pi x divided by a into differentiation of pi x by a is pi by a, okay, plus this time I'm keeping the cos as it is, pi x divided by a, and the differentiation of sine square pi x by a is 2 times of sine of pi x by a into differentiation of again sine, it will be cos pi x divided by a into differentiation of cos pi x by a. Pi x by a is pi by a according to the chain rule. Now we have 3 pi by a, which is equal to what we are left with now. We are left with, I'm taking this minus outside, so we have here pi by a and sine cube pi x by a. In this here we are having plus 2 pi by a and cos square pi by a pi x by a and sine pi x by a, right? Yes. Now what I can do, cos square x I can write it as 1 minus sine square x, right? Because cos square x plus sine square x, which is equal to 1. So here I have 3 pi by a. I can take pi by a common, so it will be pi square by a squared. So I can write it as this cos square to be 2 times of 1 minus sine square pi x divided by a into sine pi x by a, right? Next it will be minus of sine cube pi x by a. Now what we are left with? Yes, we are left with 3 pi square divided by a square. Take the sine pi x inside, so it will be 2 times of sine pi x divided by a minus 2 times of sine cube pi x by a minus of sine cube pi x by a. So we are getting here 3 times of pi square divided by a square, 2 times of sine pi x divided by a. Minus of minus, it will be plus. Put the greater number sign, minus 3 times of sine to the power of cube pi x divided by a. So we got this value for this partial derivating twice. Now this equation I want to substitute in the this equation. So here it will be what we get, which is equal to minus 16 divided by 5 times of a, its cut square divided by 2 times of 1. It is integration from 0 to a sine cube uh, pi x divided by a. For this the value, how much we got the value to be 3 pi square divided by a square into 2 times of sine of pi x divided by a minus 3 times of sine cube pi xy a. This was the value we got, right, into dx as it is. On solving this equation, I am getting, that is inside, I am taking the next slide, I am doing here, I am getting here 16 divided by 5 times of a into minus h cut square divided by 2m into, I'm taking 3 pi square divided by a square out of the integration. Why? Because it is a constant. Integration from 0 to a sine cube pi x divided by a into 2 times of, yes, into 2 times of sine of pi x divided by a minus 3 times of sine cube of pi x divided by a. Yeah, this was the term we were getting into dx. So here we are having minus 16 times of h cut square into 3 times of pi square divided by 5 to the 10 into a cube into m, right? It is from 0 to a. On solving inside the integration, I get directly I am writing the value. Solving integration, I am writing the direct value because it is consuming too much of time. So let me write the value of this integration to be 12a minus 15a divided by 16. So I'll get the final answer to be equal to 9 times of h cut square pi square divided by 10 times of m into a square. This is the expectation value. Here you need to take the sine cube pi a inside this. You will get the sine to the power of 4 pi x divided by a. Here you will be getting sine cube sine to the power of 6 pi x divided by a. For this, the integration value you need to find separately. So it is the standard integration value we must know. For this, the first one, the value will be equal to sine to the power of 4a. It is equal to 3a divided by 8. And for the sine to the power of 6 pi x divided by a, for this the value is 5a divided by 16. We must be knowing this value. After applying, we got this answer. Yes, now which is the right option? Option C is the right option. This was the lengthy question. Better not to attempt these kind of questions because it is consuming too much of time for solving. Thank you for watching.